First off, I'd just like to thank Saga and the team for organising such a great event. I know it's early on, and it's going to be a long few days for a lot of people. So thank you for the team for all the effort they put in to actually make this event happen at the last minutes, but also thank you to all you guys girls for attending. So I'm going to talk about event-driven microservices with Azure Functions, Event Grid, and Cosmos DB. Just make sure you can hear me. Yes, I can hear you. Good. So who am I? So just very briefly, I think I've already been introduced slightly, but I'm Microsoft MVP for Azure. I would have been an integration MVP in the old days, but of course that's all changed. I'm Microsoft Regional Director. I'm one of the administrators for Global Azure. We used to call it Global Azure Bootcamp, but we're doing a bit more with it now. I help run Global Integration Bootcamp, integration down under, and a bunch of other things. So because this is a fairly short session, I won't dwell too much on what I do. So what are we going to talk about today? So this is it, microservices architecture. So we'll just go through that very briefly with a bit of concentration around some of the stuff that I'm going to be talking about in the demo. I'll talk about Azure Functions. I'll probably go through that quite quickly because there's a great session by Jeff Holland coming up. I think it's tomorrow. Most things are tomorrow for me because it's quite late already here in Perth, Western Australia. So there's a session coming up tomorrow. I'll talk briefly about Event Grid, but I know there's a session coming up a bit later today for most of Europe and the US. So I'll just briefly go through that. I'll talk about Cosmos DB, and I'll talk about the scenario that we're going to run through, which is an order processing scenario. We'll do a demo, and then I'll do some wrap ups. That's how we're going to go through today. So multi-tiered architecture. So this is the old school, if you like. So I think probably we've all built one of these over our time. We've all been involved in some of them. Anybody who did a lot of stuff around service-oriented architecture many years ago will have probably built something very similar. So I've put some pros and cons on the side there. I think you've probably got some of your own, but I'll just go through the ones that I sort of see as fairly key to me. I've mentioned separation of concerns. There is a degree of separation of concerns with that business logic that you have in that diagram. They largely be sort of business transactional flows. I'll explain why that's different to microservices shortly, but as long as you're careful and as long as you mock out the various parts that you're doing that can be mocked out, then you have a degree of separation of concerns. You have easy testing to a degree. And I say low service orchestration complexity. What do I mean by that? I mean, you don't really tend to have services calling too many other services because you have an atomic process from a transactional perspective inside the business logic that will do something. The downside, of course, I've purposefully put data access and UI across all of those things because quite often, we've all been at fault for this, we'll build a monolithic data access layer against a really sort of basic standard single data structure at the back end, and then we'll include that in every single service that we need to use it with. We may, if we're really, really naughty as well, include some of that in our UI layer, but hopefully we don't. So I've said there that mini monoliths reinforce heritage thinking, heritage rather than legacy, of course. So the bad thing about that, of course, is that means that that data access layer is coupled to everything that you're using, and the UI is pretty monolithic as well. So when you come to change something, particularly if you say update your database and you regenerate your data access layer, you've got to change a lot of other stuff, potentially. And that obviously reduces agility. It reduces your ability to actually do things like scale these units separately. So all of that stuff is pretty important, but it's all the stuff that we traditionally spent our time building over the many years that we've been building things. So why is microservices different? There's a lot of views about microservices. Do they mean 5 lines of code, 100 lines of code, 1,000 lines of code? I don't think it's really that simple. They are, so anybody who's built a microservices solution will have probably heard of domain-driven design. So you do your business modeling around your domain, bounded contexts, and so on and so forth. So in this case, what you'll do more readily is break your architecture down into essentially objects and their data stores and the processes that happen on those objects. So it's got some pros and cons again, of course, and again, you're free to have your own pros and cons in all of these. So clear separation of concerns. There's very clear demarcation points throughout your entire architecture, which makes it very easy to test and build. Single responsibility. So say the microservice on the left-hand side there could be an order service. The middle one could be a customer service. So you've got single responsibility from an object perspective. Single deployment boundary, so you can deploy these things separately very easily, which means that you can also scale them very easily because, for instance, customer service would not be as heavily hit potentially as an order service. And I say use the best skills for each service, because another key thing about this sort of thing is you can use the best data store, you can use the best language, because all of these things are being written on their own and in isolation. Best skills doesn't necessarily mean that, of course, because best skills can actually just mean the skills that you have in-house to do the work. So best skills may not necessarily be a technical choice, it may be a functional choice. The downside, of course, is that there's much more orchestration complexity, because now these things aren't potentially, although they can do, aren't potentially calling each other as much, and they're not bound into each other as much, and they're not bound into the data stores at the back end. And of course, that leads to the point where if you update one data store, how do you tell another data store that there's been an update? So you have some kind of consistency of state across your entire application architecture. And that leads to the natural consequence, of course, that if you've got things updating more than one thing, how do you deal with transactional control and compensation mechanisms and so on and so forth? How do you make sure that when you roll back something in one data store that plays through to any other data stores that are important as well? I'll come to the API gateway when I talk about some other things. So primarily, really what I'm talking about, whilst it is microservices architecture, it's also really about event-driven design. So here we may have a bunch of services. This is relevant for my demo in a little bit. So we've got an order service, an inventory service, invoice service, fulfillment service. And typically you may well have them talking to each other. You may well have a service bus in the middle that's doing some management of messaging as well. But of course, that is very much the order will call and get a response, or it may be asynchronous. So what's different with an event-driven service? Well, I guess you basically have an event service in the middle. So I'm going to be talking about a couple of ways that we have that event service, and how we react to that. But essentially, this is not that dissimilar to any kind of good quality service architecture where you're using some form of publish and subscribe architecture, except that here you're reacting to the events rather than sending messages around. So I said I'm going to talk about microservices. So the first thing I'm going to talk about really is patterns. So like most other places, traditional software design, I'm sure we've probably all got a copy of enterprise integration patterns on our bookshelves. I've got it just over here in the back of my room here. So I've read that cover to cover many, many times over the years. And not surprisingly, in the microservices architecture world, a bunch of key patterns have started to become fairly popular. I urge you, and I'll show it in a little while, I urge you to check out this site, microservices.io. It's a really good site by Chris Richardson. He's really open and friendly guy as well, Chris. I'm more than happy to answer questions. But that's the site that I always go to in terms of looking for patterns that I'm going to use for my particular solution. Excuse me. So for the purpose of the scenario that I'll be talking about later on, the three that I've actually chosen are database per service, Saga, and transactional outbox. There are a bunch of other ones, but these are the ones that I think tie together really well from a functional perspective to talk about event-driven architectures, and also from the functions of microservices architectures, they're microservices patterns, and they fit very, very well with the technology choices that I'm going to be talking about around functions, Event Grid, and Cosmos DB. So we'll just launch into those very quickly. Okay, got 20 minutes left, that's good. So database per service, not surprisingly, as the name suggests, is really about having that data store that is specific for the needs of the domain objects that you're particularly thinking about and building at that time. This is kind of, I think, really the typical view of microservices that everybody sees. We're going to have a separate data store. We're going to have a service layer above that just deals with that data store, and then we'll think about the other stuff that we need to do in order to solve the problems. Microservice architectures, by their very nature, tend to be slightly more complex. Of course, going back to what I was saying about the services generally, you can imagine that the customer service probably doesn't get hit quite as often as the order service. So second way about being able to scale, you can scale these things completely separately. I already mentioned about the language, about the best skills for the job. It may well be that you've got a bunch of people who know how to do the order service and they're C# developers. It may be that the customer service service.
Being able to separate these things into separate units of work not only helps you build the thing separately and maintain it separately and scale it separately, but it also means you can use the language of choice that is most appropriate, and of course the data stored at the back end. But of course that does come with some negatives. Big negative that we can see here, the customer ID is in the order table. So how do I get the view of my customer, say the credit limit, and the order details into that view state that I'm going to be showing to the physical customer? So you do get that degree of having to actually do cross-database queries, which can't be done easily. So you probably need some kind of aggregation tool or an API gateway. That's why that API gateway is there, or maybe another service that evidences that back up. But it does mean that you add that additional level of complexity. And of course, that also plays into the fact that if you add that complexity from reading, you're also adding complexity when you're writing. So there's a potential transactional control there. And it's all about how we might solve that particular problem. So the next one I want to talk about is Saga. This is a pretty well recognized pattern generally in software architecture anyway. But in the context of microservices architecture, this particular version of the Saga, and I'll show the other one when I do my demo just very briefly, is called the choreography-based Saga pattern. And it uses event channels rather than a messaging channel. So that's the big difference. The other one that uses the messaging channel is an orchestration based Saga. But for this particular one, these services are completely independent. So they're just sending events onto a channel. And if they're interested in that event, they subscribe to that event. And you can probably see where I'm going with this. I talk about event grid. Event grid is a topic and subscription process. And that's why it's going to form a fairly large part of my demo. Excuse me. But again, the problem you can see here is that if you're passing that event from one service to another service, if that service fails, because it's not physically connected, if that service fails, how do I deal with transactions? So the customer service doesn't get called, or the customer service does get called, sends a message back to the event channel, back to the order service, but the order service doesn't respond. How do I make sure that things are essentially transactionally controlled, rolled back, or compensated appropriately? So one way of trying to wrest some transactional control is with a pattern called event sourcing, where you put all your events in one place and anything can read those events. So it's very popular in something called CQRS, which is where you can separate your reads from your writes and have materialized views of your data. So if you're interested in that sort of area, then look up event sourcing. I'm not going to talk about that one. The thing that I'm going to talk about, because it's actually more relevant to the demo that I'll be doing, is actually the transactional outbox. So in this case, what you do is when you write to your service, or when you write to your data store, you atomically write not just the record, but also something that says something has happened. So in this diagram here, you can see it's called an outbox table. So essentially, it's two-phase commit within inside that service, but it's not outside the transaction boundary of this particular database. You then have something which relays that table rights, the outbox table rights, to a broker, which can then publish it so as that can be subscribed to. So that's the process, and the reason why this is relevant is because I'm using Cosmos DB, and we'll talk about the specifics of why that's relevant when I actually talk about Cosmos DB in just a little while. So we'll just very quickly, because I'm aware that these will be talked about quite extensively this week anyway, just talk about Azure Functions, serverless compute. So it's one of those cloud native applications that we were talking about that John mentioned generally. So different types of payment mechanisms, pay-per execution, premium plan if you want pre-warmed instances so you don't get that shock of a cold start. It's event-based, which is why I'm using it for my scenario, and also because I absolutely love Azure Functions. You can't actually see it, but I'm actually wearing an Azure Functions t-shirt. So I'm going to be talking about the Cosmos DB trigger, the HTTP trigger, and the event grid trigger today, but there are a bunch of others. But again, it's based on triggers. So something happens, you react to the trigger, and as a result of reacting to the trigger, you do something. And naturally, Azure Functions are a great fit for this because they tend to be fairly low code in terms of the number of lines of code. You don't tend to write thousands of lines of code in an Azure function. So from the output end, there are a bunch of services that you can push data out to. I'm going to be talking about Cosmos DB and Event Grid. There's Service Bus and a whole host of others. The key point from when I'm saying about using the best skills for the job is it supports many languages. There's the list of languages there: Python, C#, JavaScript, PowerShell, and Java. They're all the languages that it supports, so you can use the right language for the service that you're writing. So that's a key point. Excuse me. So for Event Grid, what we have here is we have a bunch of sources. So over here you can see there's storage, resource groups, Azure subscriptions, a whole host of other things. At Build, they announced partner events as well. So they've got a link up from Auth0, which will publish. You publish into Event Grid, into a topic, and then you subscribe. And there's a whole heap of things there that you can subscribe with. And again, I'm sure that this will be covered in some of the services, in some of the presentations over the next couple of days. The key thing I'm going to be talking about really is webhooks. So with webhooks, essentially it's just an HTTP hook that's obviously you publish the event to, and I'll talk about what that basically means. But in terms of Event Grid itself, reactive programming, so it's push, not pull, so it's pushing to an endpoint. There's a bunch of abilities to filter messages that you're subscribing to. And I'll talk through some of that when I show you how to create one. It's very quick. There's a bunch of really great numbers there in terms of the events per second and subscriptions per region and the latency. There's transactional failover, but the thing that you need to consider is that the events are ephemeral. They're not there forever. There's a 24-hour retry, and when that's not happened, when it doesn't get delivered, you can either dead letter them, and then you can process the dead lettering, or they just disappear. So you just have to bear in mind that when you're doing your stuff. So next, I'm going to talk about Cosmos DB. I won't dwell too much on this because it's just, I suppose, almost like a marketing slide for Cosmos DB. So it's a multi-model NoSQL database. So it supports those things across the top there. I'm going to be talking about MongoDB today and SQL, the SQL API. So those are the two that I'll be using today. But there's a bunch of other things there as well. Global scale, so you can just essentially click a button and say, I want this data replicated elsewhere. Very, very highly available, super, super efficient and very, very low latency. Different consistency models. So remember what we were saying about transactional control and state and so on and so forth. You can imagine that you have something where when you write something to the quorum of servers, you want to be able to read from all those servers immediately with a committed transaction. So that's the strong end of the consistency levels, all the way to eventual consistency, where you may get some degree of a dirty read off of one of the servers, so you won't necessarily get value. Announced at Build, again, there was already a degree of Spark integration, but they announced Synapse Analytics link at Build, which means that you can essentially get all your data and Synapse Analytics to start running queries across it, which I think is fantastic. So I'm really looking forward to that. So the key thing around events, though, and what I was talking about in terms of the transaction outbox, is there's this thing called change feed, and that's important because currently there's no Event Grid support for Cosmos DB. What change feed is it's that forward-only log. So when you put data into Cosmos DB, you either insert or you update, an entry gets written to the change feed, and you can react to that change feed through Azure Functions, because Azure Functions has a Cosmos DB binding trigger, Cosmos DB trigger, which fires every time something lands in that change feed. So that's where you get your event-driven processes with Cosmos DB. It says there it's an ordered list of committed changes. Deletes are currently not implemented. They have announced they are looking at that, so that's good. So that means that obviously you have to find a different way of doing deletes. A fairly obvious way of doing that is to have a delete flag on your record, and then when you update that delete flag, it will be pushed as an update into the change feed, and you can do what you need to do to process it. The only other thing to consider there, and this is, again, they announced this at Build, but this is due to change soon, is that it only keeps the latest change for intermediate changes. So currently that means that you either have to make sure you process every single time a feed is read, or every single time a record is written to the feedback, or you have to just make sure that you're only that the last write is actually the correct solution for your particular applications. That's just something you need to bear in mind when you're using this. So now to my demonstration. I've got about 10 minutes left, that's good. So, so I'm going to talk about a pretty simple order fulfillment process. So I've got a cart that's written in C# and is writing to a MongoDB. So I'm just going to read some stuff out, or write stuff to a cart. And then going to read it back to make sure that it's actually worked. And then I'm going to submit that cart, and that process will create an event grid event. So the order processing service, which is written in C# and uses the SQL API in Cosmos DB, has got a topic that's got a subscription to that, and it will read that and will write a record to Cosmos DB. So we know that when we write a record to Cosmos DB, something gets written to the change feed. So we use the change feed binding, so essentially the Cosmos DB trigger binding in functions, to create an event in another topic that will be read by a JavaScript service, which will create another topic. The reason this is a bit all over the place is because I just want to show the functionality. Of course, you may not actually build something like this. Because I've written that event to an event grid topic, I'll read that from a subscription. I'll then update the record. So this will be an order record. I'll update the order record. Again, we know that an update, so that's the two processes, the insert and the update, will trigger an event. So that will be read by a JavaScript change feed function, which will write something to an event grid event topic, and then eventually we'll push that out to a Python service, which will just react to that. And that's really just to show that Python is happy to play in this game as well. So without further ado, I shall just come out of this and just hop into a few things. So first off, I wanted to just help my back, come here and just show you this microservices.io website. It's very, very good. So I'm talking about database service per service, which is here, Saga, which is here, and then transactional outbox, which is down in the middle bit here. But if we go in Saga here, and the reason I'm showing this now, so there's the choreography-based Saga, which is the one that I showed you, and there's this orchestration Saga, where you may have a degree of, so you create your Saga, excuse me, and you may have your your processing on the edge of your, essentially on the edge of your service. So I think this is a really good use case for durable functions. So another time when I write this presentation, I'll use durable functions for that. So I think that's a really good example where you can use that. But I'd certainly urge you to go to this site and just have a play around, look through, because it's a really, really good site and gives you some great ideas and pointers as to what you can do with things. But what I wanted to do is I wanted to show you how you create one of these services. So the one thing I need to do first is just start my functions up. So let me just, my functions runtimes. So I've got 3 instances of Visual Studio here, because I've written, so what I've done when I've built my services, I've partitioned them by not domain object, but by language, just so as I can organize them and keep them nice and tidy. But of course, if you're writing these properly, you do them by services themselves. So these are coming up now. So what I'm going to do is I'm going to go in here. I've got something, here's something I prepared earlier. I'm going to copy that. And I'm using a thing called ngrok, which just allows me to have my local host exposed out to the internet. So that's what this is doing here. So I've got a backorder process event grid topic here. So this is an event grid topic. So I'm going to create a new subscription. I'm going to give it a name, which is process inventory, say. I can choose whether to use the event grid schema or the cloud event schema. The cloud event schema is the schema that's been published to the CNCF, so the Cloud Native Computing Foundation. So that's a standard. Or I can use my own schema. I'm using the event grid schema because currently the event grid binding only supports the event grid schema. I mentioned about filtering, so I can filter by the event type. And it will become clear as to what these are when I show the code. I can filter by a subject, or I can filter by some content of the data. What I'm going to do is I'm going to add a service now. So I'm going to add a webhook. I said I'd be using webhooks. So the key thing about using the event grid binding, which is why it's really, really good to use it, is because, as I shall show you just very quickly here, if you can just write your own services as HTTP endpoints and use those as a webhook, but if you do that, you have to, in your service, write a validation step, because you have to validate that you essentially own that service. And there's a process that you have to do, and kind of a security handshake that you have to do in order to get that. So what I thought I would do is just show you that actually the reason why you do it in the binding is because if I go here now and I click create, you can see here that something's running in my service. Even though I'm only creating a subscription, something is running in my service. And the thing that's running in my service is the handshake. So it's performed that handshake for me. So I don't have to worry about creating the subscription handshake when I use the event grid binding. So what we'll do is we'll kick off the processing now, and then I'll walk through the code as we do that. So I've got an order table, which I shall show you just to prove that there's no smoke and mirrors here. So I've got an order table here, which contains no data. Fingers crossed, I cleared it out earlier on, yes. And this one also contains no data. That's good, yeah, so just takes a couple of seconds, Mongo's a bit slower. So I've got a couple of services here. I won't call these just yet. I'm going to call get cart just to prove that doesn't bring anything back currently. But what I'm going to do is I'm going to insert a record into my cart, which is MongoDB. So currently the bindings, the trigger binding and the input and output bindings for Cosmos DB only work with the SQL API. That is due to change, I think. But so what I'm going to do is I'm going to insert this record into the cart. So it's just a couple of items that I'm inserting into the cart. So we'll just do that very quickly. And just to prove that that has worked, we can just try and get that cart back again. And there we are, it's back. So now when I click this checkout, essentially what I'm going to do is I'm going to take this and I'm going to create, if you remember, I'm going to create an event grid event, right? So I just want to make sure that these things are all running. Yes, they are, that's good. So we'll click send. And we'll see that I've stopped into here. So this is a HTTP trigger. And what I'm doing is I'm creating an event grid output. So this is the event grid output binding that I'm using here to create an event grid event and sending it to this topic endpoint with that key setting. And it's very, very simple. It's essentially this piece of code here. So I'm creating my event and I'm pushing it to an output. So if I just run this on, so this is my checkout cart service. It's now coming to my next service, which is an order submitted service. So here I'm using the event grid trigger, because remember I sent that to an event grid topic. So this is subscribed to that particular topic. And I'm then using the Cosmos DB output binding to essentially take the contents of my record that I sent through my cart and push it out to my orders table in Cosmos DB. So we'll just do that. Now, what do we know about when we insert a record into Cosmos DB? We know that it triggers or it creates a change feed record. So I've got two functions here. One is in JavaScript. So you'll notice that I'm saying if order status is accepted, which in this case it's not, the order status is pending, and we'll see this in a minute. Now, of course, I could have added a filter to this event grid, I could have added a filter to take this out, but I decided not to. But if we go through this, you'll see that it doesn't actually run. And then if we go back, because it's not accepted, if we go back to this one here, you'll see it's pending. And if we run into here, you'll see it does run. And then when we do this, we're doing another event grid event here. So this is now going into the function, the Azure function that's using an event grid trigger. This is how we essentially write an event grid output binding, event grid output. And in the functions.json, this is how we create the bindings. So we have an input binding here, so that's our trigger. And we have an output binding to another event grid output. So we'll just go back here and run that through. And I'm running very short on time. And then we come in here and we've got an order accepted. This is using the event grid trigger again and outputting to an event grid a change feed, because it's now updating the documents. So I think, sorry, I apologize, maybe I'm about 2 minutes over. So that's doing that. And now we come back again, we're going through that change feed process again. It's not pending anymore, it's now accepted. So we come in here and it's accepted. And then the last part of this process is going into my Python function to process that. So we can see that what we've done there is we've used the change feed, we've used event grid, and we've used Cosmos DB input and output bindings, and we've used 3 different languages, all of which have worked perfectly well with all those services. So that's a very, very quick process. I had to go through fairly quick. Let's go back to the slides. And then just 1 second whilst I start that back up again. But of course, the one thing I haven't done is talk about security. I haven't talked about using things like application insights, because if you can't see inside your application, you're not sure what it's doing. I haven't talked about API management for authentication potentially, or additional layer of abstraction, or a degree of that gateway control. I didn't have any exception handling. We haven't talked about robust eventing around that deletion process because they're ephemeral events. I didn't use the cold tier, the premium tier, beg your pardon, and I didn't use CI/CD. So those are all things that you'd actually obviously do in a real scenario. So just to wrap up, key takeaways from this particular discussion is Cosmos DB change feed trigger input and output bindings only work with SQL APIs. So that's just something to bear in mind when you're building a thing. The change feed doesn't support deletes currently, but they did announce that. Event grid binding only works for event grid events. Calling service is still okay, but maybe consider a layer above that, like an API gateway to do that orchestration for you. Don't think you have to build microservices. Sometimes a monolith, or at least as I mentioned here, at least the impression of a monolith is the right answer, and you can move to that microservices architecture over time if you need to. But, and this is a key point I made very early on, it does add complexity, so you need to consider the various things it says there: delivery and processing, service coordination, consistency, all manner of other things. So it just adds complexity, but of course it does add agility as well, and it expands your options in terms of making sure you've got lots of languages you can use, and it does give you the opportunity to move to that over time, and then of course it's more likely to be future-proof because it's a newer technology. And with that, I think I'm about 2 minutes over. I shall wrap up. There's a bunch of resources here. I'll be sharing these slides anyway, and that's me. I think, let me just go to the Q&A just to see if there's any questions. Let me just stop sharing my screen as well. One difference between when to use table or Cosmos DB. So that's one of the questions, when to use table or Cosmos DB. Table is a pretty flat structure. Cosmos DB by its very nature is a document, or in the case of the way I was using it, is a document database. So actually, let me just very quickly go back to my, where are we? There. So if we look in here now, let's get my thing back on the screen. We refresh this just so we can see the cart that we put in here. So this is using Cosmos DB, this is using MongoDB, but you get the same sort of effects inside the SQL API as well. And you'll see it's just all JSON. So there's some things that you need to consider when you're building a document database around how data is related to each other and so on and so forth. With a table, of course, you get essentially that sort of CSV view. That's very useful when it comes to wanting to query things potentially. But now you've got inside Cosmos DB, you've got the ability to just essentially add very quickly and very easily Synapse Analytics. So you can actually take the data in here, and it's very, very low latency, and it's very available. It's really easy to replicate. So I can go into my replicate data globally, and I can just start choosing different regions to start replicating my data to, and it will just automatically happen. So there's a bunch of great reasons for using Cosmos DB over table, but your mileage may vary. You make your database choice based, or your data store choice based on the requirements. The other question that I have here, how to track all those distributed events. This can become hard to manage. It absolutely can, and what I've not done is essentially doing that. So this is where I mentioned about adding things like application insights, or indeed custom events that write out to another logging service. So as you'd be able to pass, say, an order ID or something that correlates this information all the way through that process, so as you'd have an end-to-end visibility of what you're doing. I don't have time to show that today because there's a lot involved in how you might do that. It may be covered in some of the other presentations over the course of the next couple of days. But yeah, I've purposefully taken a back step on showing that logging just because of brevity of time, really. But you're absolutely right; it can be hard to manage, and it doesn't hurt to have this written in some collaborative tool where where message types and so on and so forth, like you would do in a typical service scenario where you'd keep a service catalog. So that doesn't hurt to do that as well. I think that's all of the questions. I think, yes. So hopefully I've answered your questions. Please feel free to type anything else in the chat. Hard to keep track of what. Yeah. So I apologise for the brevity. It's quite a short session. So yeah. Please. The session's being recorded, so please do go back and review the session at another time. And I think with that, with the questions as well, I'm about 5 minutes over. So Mahan, back to you.
Thanks, Martin. That's all we have. We'll conclude this session. Thanks, everyone.
Covey.co